Okay, so I just wanted to do a quick video here for our lesson on solving equations containing fractions, just because I know some of you haven't seen fractions in a while, and I wanted to help you out with that. So just quickly going through the notes here, it says you're going to first find the lowest common denominator for all of the terms within the equation. Okay, and hopefully you remember how to find a lowest common denominator. One of the ways that I like to do it is I'll make a quick list of all the multiples of whatever denominator I have, and I'll do that for all the terms in this case. So if I make a quick list of all the multiples of that particular number that's in the denominator, and then I can go through each list and see which numbers match. That's one way that I like to find the lowest common denominator. Once you've done that, once you found a lowest common denominator and you convert everything over into fractions with that denominator, you're then going to multiply each term in the entire equation by that number, because then what that'll do is, you'll see here in a minute, it essentially cancels out all the denominators and turns our equation into an equation that no longer contains any fractions. So I'll do a couple examples here just to kind of get you started. So our first example, we've got 1/4 x equals 8. So I want to get everything in terms of fourths. Okay, I see that I've got 1/4 x. I want to turn that 8 into fourths. So to do that, I'm going to multiply it by 4/4 and rewrite this as 1/4 x equals 32/4. Once I have it at this point, this is where I want to multiply now by that common denominator. I'm going to multiply by 4 on both sides of the equation. And what that'll do is that'll cancel out the 4 in the top, 4 in the bottom, 4 in the top, 4 in the bottom, and I'm left with x equals 32. All right, in our second example, we have 3/5 x plus 1 is equal to 22. So I see that the only fraction I have is 3/5. I want to convert everything into fifths. So I'm going to multiply this 1 by 5/5 to convert it, and I'm going to do the same thing with the 22. Okay, so all I'm doing is rewriting those constants. So this will be 3/5x plus 5/5 equals, and then I have to do 22 times 5, which gives me 110/5. Okay, and again, when I'm multiplying by a number over itself, that's not changing the value at all, because 5/5 is equal to 1. So essentially I'm multiplying those two things by 1. I'm just doing it in a way that looks different. So now that everything has a 5 in the denominator, I can multiply both sides by 5. So just to sort of help us out here, I'm going to put parentheses around this so I see that I'm multiplying everything times 5. And I'm multiplying the other side times 5 as well. And again, what that's going to do is the 5 is going to cancel with the 5's in the denominator, so that everything else remains. So I end up with 3x plus 5 equals 110. Now this is something that's much more familiar to us. This is just a two-step equation. So I'm going to subtract 5 from both sides. That leaves me with 3x equals 105. And then lastly, divide by 3 on both sides. And I get x is equal to 35. I'll do a couple more examples. This one we have x/2 plus 7 is equal to 2 times the quantity x minus 1. So the first thing I'm going to do is I'm going to distribute that 2 and rewrite my equation as x/2 plus 7 is equal to 2x minus 2. Now this is just like our previous examples. I have a fraction here. X/2 is the same thing as 1/2 times x. I want everything to be in terms of halves, so I'm going to rewrite each thing by multiplying by 2/2. So I have x/2 plus 14/2 is equal to And I can write this all as one fraction if I want. And that's what I'm going to do. I'm going to write it as 4x minus 4 all over 2. Okay, so really, if I want to go back here, I can think of it as I'm doing this, putting parentheses around this 2x minus 2 and multiplying that times 2 over 2. Whatever way you feel like doing is alright with me, just to kind of simplify the process. Okay, so at this point, everything's all over 2, so I multiply both sides by 2. And what that does is cancels out all those denominators and leaves us with a much nicer equation to solve. X plus 14 equals 4x minus 4. Now I want to get all the variables to the same side, subtract the x over, and I get 14 equals 3x minus 4. Add 4 to both sides. That gives me 18 equals 3x, and then, oops. But it doesn't want to go anywhere. There we go. 18 equals 3x, and then lastly divide by 3 to get 6 is equal to x. Alright, for the last example I'm going to do with you, I'm going to move to what I think is probably the most challenging one on here, which is number 10. So this one, there's a lot of fractions here, so I need to find a common denominator for all of them. So we've got a fraction that is in tenths, one that's in fifths, and one that's in 20ths. So my common denominator there, I talked about making a list off to the side. You can do this if you need to. Multiples of 10, so 10, 20, 30, 40, 50. Multiples of 5, 5, 10, 15, 20, 25. And multiples of 20, 20, 40, 60, 80, 100. So I look and I want the lowest number that shows up in all those lists. And I've got 20 here, 20 here, and 20 there. So everything's going to be in terms of 20ths. So I want every single term to be in terms of 20ths. So for 1/10, that's going to be rewritten as 2 20ths. Okay, I'm just multiplying the top and bottom by 2. Fifths, I have to multiply by 4 over 4, so I get 4 20ths times x. For 3, that's going to get multiplied by 20 over 20, so I end up with 60 20ths. On the right side, that 6 20ths is already in terms of 20ths, so 6 20ths x is okay. And the minus 2 becomes 40 20ths. So again, if I wanted to show you, it's 2 over 2, this is times 4 over 4, this is times 20 over 20, and this is times 20 over 20. Multiply both sides by 20, and all of these denominators go away. I'm left with 2x plus 4x plus 60 is equal to 6x minus 40. Combine my like terms to get 6x plus 60 equals 6x minus 40, and hopefully you realize that there's something weird going on here. I've got 6x on both sides, but I have different constants on both sides. So remember, when that happens, that means you have no solution. If I try to combine the x's all to one side by subtracting 6x, I end up with the result 60 equals negative 40, and that's just not true. So there is no solution for this particular problem. Alright, so give the rest a try. I will post a key for you, and we'll see how it goes.